So the first example we did, we were asked to find an angle in a triangle. In this one, we're going to find a side length. How to determine the side length. So in this situation, we have a word problem. Sometimes the diagram will be given to you for the word problem, and sometimes it won't. So it's important that you're able to read word problems, translate it into a diagram. And I'm going to do examples of that throughout the course, and you'll be able to practice it with the homework. Let me know if you have any difficulties with it. So Andre, A, we're going to call him A, quarterback of his football team, is attempting to throw a pass to his receiver, Roberto, who is R. So he wants to throw to Roberto over here. Juan is trying to block. So he's trying to get in to block. How far must Andre throw his pass to Roberto? How far must Andre throw his pass to Roberto? So what we're looking at is we want to find, this is little j, I'm going to circle it. We want to find the distance between A and R, between Andre and Roberto, because we want to know how far he needed to throw it. Round your answer to the nearest foot. So not only does this question have units in it that we need to remember, but we need to remember to round our answer to the nearest whole foot. Okay. So we need to find the side length. Once again, I've already started because I was reading my word problem. I wanted to make sure I circled what I needed. But we're going to label the rest of our triangle. So instead of having A, B's, and C's, this time we're going to have A's, J's, and R's. So little a divided by sine A equals little j divided by sine of big J, little r, sine of r. Let's figure out what we need to use. So we know we need to use j because that's the one we're asked to find. So we're going to use that one. And then we need a full pair that we know. And if you take a look at this triangle, there's A here, but we don't have little a. We have this one, but we don't have this one. So in this situation, we actually don't even have a whole pair at all. This is kind of a problem because basically we need to have a total pair in order to solve it. Okay. So what we're going to do is, this is a typo on my part, it needs one. You need a whole set, otherwise you can't use the formula. Okay. So if you think about it, we've got 110 degrees here. It's not a typo. I just need to think for a second. 110 degrees here and 32 degrees here. Since all of the angles in the triangle have to add up to 180 degrees, we know that this angle has to be the remaining. Okay, so 180 basically, and then we're going to subtract 110 from that angle, and then we're going to subtract the 32 degrees from that angle, and you get 38 degrees. Okay, so we needed to use another step that I almost missed. I almost thought I forgot to put something down, but I didn't. Okay, we need to have that total pair. So now we've got it. So we are going to use, we have R's, so we're going to use our set. Yeah. I put tricks like that in, fools myself sometimes. Don't miss those. Try not to. So we know we're going to be using J and R. So we've got J equals R sine R. I like to write it down again. And now we're going to substitute our values into it. We don't know little j, sorry. We know big. We've got little r. And we've got big R. Okay. So once again, this one's a lot easier to rearrange because we just need to move the sine 110 over. So it's a little bit easier to rearrange it. Calculate 20 multiplied by sine of 110, all divided by sine of 38 equals 30. And remember, I think we were looking for the nearest foot. So we're going to round that up to 31 feet. Okay. Now, because this question was asked in words, this is kind of my rule. If the question was asked in words, you need to answer in words. So usually, it says solve the triangle, it says do this, and then I put a box around it generally. Not that that's a big deal. But because the question was in words, I need to answer in words. Those 3 dots mean therefore, just in case you're not familiar with that. Therefore, Andre must throw his pass 31 feet to Roberto. Doesn't have to be fancy or long, it just has to summarize what you've done. So the second question, second example, or this is the third, sorry. Solving an obtuse triangle. So if we know that triangle PQR has a side length 4.5 for P, 2.3 for Q, and 116 degrees for angle P. It says solve triangle PQR. Remember, solve means find all possible side lengths and all possible angles. Round all your angles to the nearest degree and all side lengths to 1 decimal place, just to be extra picky about it. So first thing, draw a diagram. If you can draw a diagram, draw it. I'm a visual person. Diagrams help me see it. If you can do it without it, just be super careful. So I'm just going to draw, and because it's a triangle, it doesn't give you directions, it doesn't say who's where or what's happening. You just draw any obtuse triangle. Okay. I'm going to draw an obtuse triangle, and I'm going to label it PQR. Little p, little q, little r. Now I can put my numbers on. 4.5 meters. Q is 2.3 meters. And angle P is 116 degrees. Solve the triangle. So write down your sine law. Q, P, Q, R. Okay. We need to use the ratio that we know, which in this case is P. Okay, so we know the angle for P and the side length. So we're going to use this to find, and what we need to find is we don't know this angle, we don't know this angle, and we don't know this side. So we're going to have to do three separate calculations. So let's find, and we can pick, I think we're going to have to use, you take a look at this, we don't know two of the angles, right? And this, for R, we don't know anything about R. So we're going to have to find, if we do some problem solving, some thinking ahead, we're going to have to find this angle first, no matter what. Because there's no way we can find this without this side length. And there's no way we can find this side length without this angle. So we're going to find Q first. So to find Q, we need to use the ratio we know. And we're going to use, obviously, Q. Substitute the values that we know. This is 100 and, whoops. Ooh, little p and big P look very similar. Super careful. Sine, remember this is always the angle. 116 is equal to little q. I'm going to find sine of big Q. So if we flip both sides once again, just to make our Q go to the top. Okay, and I'm going to continue up here. If we quickly rearrange this, Q is going to equal to sine negative 1 of sine 116 divided by 4.5 multiplied by 2.3. So Q is going to equal sine negative 1. And you can do this all in one calculation, or you can break it up. Doesn't matter. I'm going to do it all in one. And we're going to round it to the nearest degree. So this is going to be 27 degrees. Okay. 27 degrees. I need some more paper space. Okay. So that's angle cubed. So we can go back to our diagram and we can put in 27 degrees. Beautiful. Okay, let's do the next one. The next thing we're going to find, you have to think about it a little bit, okay, is now we have two angles in the triangle. So we're going to take 180. So angle R is going to equal 180, subtract 116, and subtract 27. Okay, because it's that remaining angle in that triangle. So that equals 37 degrees. So that one was nice and quick. Okay, that was to find R. And the last thing we have to find is little r, the side length r. So we're going to use our known ratio. Now we're going to use sine r. Substitute what we know. We know P is 4.5. Sine P. We don't know what R is. 37. Rearrange this for R. So R equals divided by sine. And I just multiplied this up to here. Sine 37. And we need to calculate that. 4.5 divided by sine of 116, all multiplied by the sine, 37. And this is equal to, and remember, all side lengths rounded to 1 decimal place. So this is 3.0 meters. So we can go back to our triangle and put in 3.0 meters. And then take a look at the triangle, make sure we have everything. It looks like we do. So we are done. We are completely finished.